In this video we look at counting permutations. So permutation is a scary word here, but let's discuss what it is. It's really not that complicated. So a permutation is an arrangement of items in a particular order, maybe like a list. Okay, so the key to this definition of permutation is the fact that the order matters. Okay, that's what's important about a permutation: arrangement of items in a particular order. So how do we count things when the order matters? So when would the order matter? Order might matter if let's say you're picking a basketball team and you want to assign each player to a position. Then it matters who goes where. So you could have a team of 5 people, and there are different ways to arrange them in other positions, but it could still be the same 5 people. So every time you put someone in a different position, they switch positions. That's a different permutation. But if you're just looking at how many ways you could count or put the 5 people on a team, no matter what position they're on, they're still the same team. So if you're just considering the team as a whole, then that is not a permutation. Okay, so let's look at another example. So here's an example where we're actually going to count. Okay, so there's a homeowners association meeting and 24 total neighbors attended. In how many ways could they select a president, a treasurer, and a secretary? Well, we can start this using the basic idea of multiplication. We have to pick 3 things, or 3 people. So we could say the first person is the president, the second person is the treasurer, and the third person is the secretary. And we know that if we're going to pick the president first, for example, and if any of the neighbors could be president, so that could be any neighbor, then there are 24 options for the president. Then we move on to pick the treasurer. If I want to pick the treasurer, I can't pick the person I chose for president, so it could be any neighbor but the president. So that gives me 23 options. And if I need to pick the secretary, I can't pick the person I chose for the president or the treasurer, so I have 22 options. So the answer ends up being 24 times 23 times 22. Okay? Now, you could certainly leave it like that. The goal of this video is not to teach you how to solve this particular problem. It's to teach you about permutations and how to solve many types of problems with the same concept. Now, there's nothing wrong whatsoever with multiplying these 3 numbers together and getting the answer. Let me do that real quick. Looks like you get 12,144 different ways that you could select a president, treasurer, and secretary. Okay? Nothing wrong with doing this problem this way, but some problems this may not be the most efficient way, or this may take way too long, so you need other ways. So I'm going to teach you some things that you could apply to other problems, and hopefully you'll find interesting. So 24 times 23 times 22. It looks like it's going to count down by ones, right? 24 times 1 less is 23, times 1 less is 22. Another way of thinking about this is thinking of it as 24 times 23 times 22 times 21 times 20 times 19, all the way down to 3 times 2 times 1, all the way down to 1. Now clearly that's not the same thing, but if you take that and you divide it by 21 times 20 times 19 times 3 times 2 times 1, then that is the same thing. Because you could see that the 21s cancel, the 20s cancel, the 19s cancel, the 3s, 2s, and 1s all cancel, leaving behind just the 24 times the 23 times the 22. Now that can be useful because now that's the same thing as, so this guy equals this long fraction. You don't want to actually write that out ever unless you're just doing it to learn, to understand. What this really is on top now we have 24 factorial, 24 times every whole number down to 1, over the bottom is 21 multiplied by every whole number down to 1, so that's the same thing as 21 factorial. So this is kind of a cool way to calculate 24 times 23 times 22. You should try this in your calculator and you should still get 12,144. Okay? So, again, it doesn't matter to me which technique you might use, but there's value in understanding what's written in blue here. Okay? Now, there's another way to do this as well, and this is really what is the point of this video, is the selections we make up here. Each one is a permutation. Each choice is a permutation. Let's say that Alan, Bill, and Cindy are 3 of the 24 neighbors. Well, I could choose Alan to be president, Bill to be treasurer, Cindy to be secretary. I could choose Cindy to be president, Alan to be treasurer, and Bill to be secretary. Each one of those is a different option, right? Because I have a different president, treasurer, and secretary. So each one is different even though it's the same people being chosen. The order here matters. Order matters here. So that's why each choice is a permutation, because each different order is a different count. So another way to figure this out is using permutations. So how could we count using permutations? So the language we associate with this is you think from however many, so from your total, which is 24, we need to choose 3, and we have to know the order matters. Okay, so how do we describe this? How do we calculate this? Well, 24 choose 3. 24 choose 3 is actually a phrase in mathematics, and it can be calculated one of 2 ways. And so what we're going to do is look at the way to calculate when order matters. And so 24 choose 3. When order matters, you put a P between them. So this is 24 P3. Maybe 24 pick 3 if you like. But from 24, choose or pick 3. And we're using a P for permutation. Order matters, so this is permutation. Okay? And your calculator should have a button that looks like, could be many different things, but typically it's like NPR. And so you type 24, hit this button on your calculator, and type 3, and it should spit out the same answer we got up here, 12,144. So you can avoid the factorial notation completely as long as you understand that from your 24 total, you're choosing 3. The weird thing about this is you put your total first, okay? But that is permutations. Let's see if we can do another example. Okay, so in this example, a contractor is going to start building a subdivision. He's going to build on 9 lots to get the first phase of the subdivision started. He can choose from 13 home models. How many ways could he arrange homes on these lots? Well, this problem is a bit vague. If there's no restrictions, he could choose the same model to be on all 9 lots. So we're going to add a condition to this. Okay, so here's the modification. Now he must build a different model on each lot. So The order is going to matter here because he could arrange these houses in different ways. So this implies the order matters. And because he's building a different model, that means each choice, each option, let's say, is unique. That's important. Maybe I didn't stress that enough up here in the last example. Whenever you choose 3, you have to pick 3 different people. Okay, so permutations only work if you're choosing unique options. You can't choose the same thing more than once. Okay. Now, because of order and each option is unique, we know that this is going to be, we're going to look at permutations. So, how many total to choose from? Well, in this case, we have 13 models to choose from. And how many do we pick? We need to pick 9. So this problem is a 13 choose 9 problem where order is important. So the way to calculate that is 13p9 on your calculator. Looks like we have 259,459,200 options, arrangements, let's say. That's how many different arrangements he could have on those 9 lots. Seems like a lot, and it is, because he's got 13 houses he can pick from. But that's how you can do this. If you understand that it's permutations, then you can use this feature on your calculator. Now this feature also means, just to remind you, it means you've got 9 spots, 13 choices for the first, 12, 11, 10, 9, 8, 7, 6, 5. So multiply those together, or another way to think about it is 13 factorial over, canceling from 4 down means I'd need to divide by 4 factorial. So all of these are completely equivalent.